Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Hello, and welcome everybody to another episode of the AC Trailblazers podcast, where we interview the most amazing founders of the AC. Today with us, we have Stijn Jansen. He's the Chief Product Officer at VIKTOR, a Python-based low-code platform that empowers engineers to automate repetitive tasks and build web apps for civil, offshore, and structural workflows. With a background in aerospace engineering from TU Delft, his career spans from project engineering in Chile to head up development and COO at VIKTOR. Stijn specializes in parametric design, knowledge-based engineering, and automating design processes to make engineering work faster, better, and more enjoyable. At VIKTOR, he works closely with teams to create impactful solutions, unlocking true engineering potential, and empowering them to focus on solving complex challenges. Stijn, welcome to the show.
Thank you, Valentin. Really nice to be in the show.
Yeah, it's great to see you. People don't know, but we met in June, right, in London.
Yeah. At the next dev event. Yeah. Really
exactly.
cool event, I thought, or at least I really enjoyed it. How did you like it?
No, it was really fun for me. I think it was great to see. I mean, it was kind of like one star a startup next to another and compare them. So and of course you were included there, right? And so it was really fun to see the different like processes you can do with one or the other. So how was for you?
Yeah, the same. So it was my second time. And it's just super cool to see also how compared to last year, because of course, hey, you have in the industry the big incumbents like Autodesk and Bentley and but then you of course now have a lot of I think startups and scale-ups, and especially I think in the let's say a bit of the conceptual design phase. So Snapshot was I guess one of the sort of first new ones, but then you have now Motif and Arcol, and just so much happening. And also if I already compare it to this year compared to the year before, you can really see that this is a clear boost. And also I think if you look at the investments that are going into new software in the industry, so super excited to see all these things going on.
Absolutely. And before we get started, can you tell us? We can hear a little bit of an accent.
Yeah.
Can you tell us where you're from and how you started, how you ended up in the AC tech world, man?
Yeah, of course. Yeah, so I am from the Netherlands, so Dutch, and born and raised here. I studied in Delft, University of Technology, as you already mentioned. So I did aerospace engineering, and then so during my studies, I also learned to program, and that was just one of the courses that was just required to get your degree. And in the beginning I actually didn't like it, so I first started with Java courses, and I don't know, but then at some point it started to click, and especially during my master's, I did it was then called basically it was all around what we called there knowledge-based engineering. So it was really about, okay, how can you basically, you have all kinds of disciplines in aircraft design, right? You can have the aerodynamics or the structural or all the systems, etc. But at that department, we really focused on how can you sort of bring that all together to come up with the design of an aircraft. Because at the end, and that's, I think, same holds for a building as for an aircraft, at the end, it's a compromise, right? So an aircraft doesn't have the optimal aerodynamic shape. It doesn't have the optimal structural shape, but it's really finding the optimal balance between those disciplines. And there we did that mainly by using programming and the what I really like, sort of the big project or the big goal of the department was, can we come up with something that can design an aircraft or an optimal design of an aircraft just based on requirements, so that you can say, I would like to have an aircraft which has this range and this many passengers, and just come up with the optimal design, and then by integrating all the different analysis, etc. So I still remember really well that I did things like, okay, how can you optimize a wing for both structural as aerodynamic properties? And I just saw all these iterations going on, the wing changing shape, and then seeing at the end, okay, this is sort of the optimal weight versus lift distribution, those kind of things. So there I really started to really enjoy programming, and especially in combination with engineering. So yeah, I just really like that combination. Then I joined just two other guys who just started a company, Peter and Wouter. And at that moment, actually, we had some things we were doing. So there were a few technologies we were working on, but also we did some engineering ourselves. So mainly structural engineering. And we just used this automation to automate our own work, basically. So this was in 2013. But what was for us quite logical to do, just see, okay, where's repetitive work? Let's write some code, automate it. We noticed that was in the industry not that common. So then we really saw, okay, this is something that we, first of all, really liked, really focusing on that automation part, but also that there was a gap in the industry. So that's how we then started working on VIKTOR. And at that moment, we also became more active in the AEC industry, because that was where we I think it was a bit of a coincidence in some way, where we just had our first customers who were in the civil industry and in the building industry. But also I think there, because you have sort of repetition, but everything is different, and there we saw this really nice opportunity. So that's how we then started to develop VIKTOR, and focusing on the AEC industry, and then first in the Netherlands, and then later on in we are now having customers all over the world. No.
That's a great story on how you went from aerospatial engineering into construction. And I'm just curious, right? I'm an architect, so I'm biased when I need to speak about our industry, but you come from a different industry, and now you have been in our industry for a long time. What do you think the differences are, or what our industry lacks compared to aerospace, which it's a different industry, right?
Yeah.
And you build one really complex plane, and then you build it so many times. Our industry is like, it's never the same plane, it's never the same building. But what do you think you can bring from that industry to ours?
So I think that's what you're saying. I totally agree. So that makes it really fundamentally different. Let's say the fact that you have let's say one thing that you design that you then build multiple times. So I think that holds indeed for aircraft, but also for, of course, things like automotive. And I think by having that, it's easier, I think, to optimize that thing further, right? You just have the return on investment of further optimizing just becomes easier. So I totally understand also now, being in this industry, that it's just very difficult, because it's not only, let's say, that each project is different, but also let's say, also often the team or the group of companies in which you work together is also different, right? You have another engineering firm, another architect, another contractor, and then all of these companies work together with different software systems, and then sort of so this makes it, I think, on all sides really complex to, let's say, continuously, because that's usually what happens, I guess, right? Year over year or project over project, you try to improve. But I think because you have this sort of different setup and this different project all the time, I can imagine it's quite challenging. But I think what is something that I think can be really interesting for the industry is to think about more about productization maybe of certain things, right? So of course some things are what I sometimes notice is that, okay, of course every time it's different, but if you look at certain maybe subcomponents of a building, they are actually sort of, I don't know, a foundation pile is always a foundation pile, but maybe the soil conditions are different, and of course the sizes are different. But at the end, you can approach this design process in the same way, and I think there's where parametric design can come in really nicely, where you can say, okay, how can we have certain components and view them as more of sort of products, and trying to improve every project on, okay, how can we further optimize that process? Yeah.
No, that makes a lot of sense. And I do think that that's key to understand why also, because there are two components, right? Design
Yeah.
and engineering. And
Yeah.
I do feel that when design it's not using a parametric logic, like you said, using reusable components and or prefab or like
Yeah.
whatever allows you to make the engineering faster.
Yeah.
Like I feel that's a big problem, because you could say, yeah, I'm gonna automate the engineering, but the problem is if the architects are using different materials or different components, and it's so hard to do it downstream
Yeah.
when you have to do the engineering. So
Yeah.
it's just interesting how both of them are related. I don't know if you get the same feeling that
Yeah.
you deal a lot with engineers, and
Yeah.
I don't know what you think about that.
Yeah, definitely. And also I think so that's sort of what we typically see, because we work with architects but also with contractors, and there's sort of always this, I think, challenge where an architect, so it's a bit of an exaggeration of the actual process, but let's just put it a bit strongly put, is that the architects, they design something which is then super fancy, right? And then, and this is at least what we see often, of course, also in the Netherlands. And then there's a contractor involved at some point in the process, and then they say this is too expensive to build, basically. Okay, so let's change it to something which is, and then there's sort of this whole process, right, where the architects think, okay, now we end up with something ugly which is cheaper to build. And then and I think here what I really like, there's a really nice example of a project in Rotterdam, which also won all kinds of architecture prizes, where basically the contractor was involved very early, and it was also because they needed to build this on already a building which was already there, and then on top they built sort of a whole set of apartments. But already the contractor came at first with boundary conditions where they said, okay, this is where we have, for example, the primary structure should look like this. And because there were very clear boundary conditions, at the end, the architects could, be creative within these boundary conditions, but they knew upfront already, okay, if we keep to these boundary conditions, then actually we will have something which is actually also cost effective to build. And there I do see that there's a lot of potential, I think, for making sure that also the contractors are maybe earlier involved, setting up certain boundary conditions, and then within that playing field that you have creativity as an architect to come up with something that is then both cost effective and of course architecturally interesting.
No, that makes so much sense. And if you think about it, even subcontractors, it happens with subcontractors as well, right? They get involved, and then suddenly they say, you know what, this material that you put on the specs, it's not available. You cannot build it. So let's change this. And I do feel that the earlier you can involve every player in the design, the better. But also, I don't know, I think we're going to get into a rabbit hole, but contracts, right? Like, why are you supposed to waste your time as a subcontractor or general contractor being involved earlier and invest hours if your contract is a closed budget contract where the less amount of hours you put into it, the more money you get. So
Yeah.
I feel that like it needs to be a better way of involvement between all the different parts, where if we save more money, we all get more money. That way we're more, we're more willing to invest hours on the earlier part of the process. I don't know if that makes sense.
Yeah, definitely. And I think the other way around. So let's say from the architect or from the engineering firm, for example, let's say if they automate their work, right? At the end, their business model is hours basically, right? So, and it depends a bit on the contract, but if you have a contract which is on an hourly basis, what we see a lot is that then what is the incentive for an engineering firm to automate their work, right? Because at the end, or maybe automate, but also maybe you can optimize your design further. So let's say that you have automated this process, and because of that, you can just really come up with the optimal structural design, saving material and etc. But if then this then at the end ends up in the wallet of the contractor, and you don't have an incentive actually as an engineering firm to optimize your design really, and then again, so there I think, yeah, you really see that these business models of these different customers often don't lead to automating more or optimizing more. Yeah.
That's it. That's a great point, and it happens with architects as well. But I do feel engineers, it's much more easier, not easy, easier
Yeah.
to automate, right, the calculation of a structure or the MEP or whatever you're doing. And it's true, if you're gonna be paid T&M, right, what's your incentive? Like if I used to charge 200 hours for a structural calculation, and now with the VIKTOR, for example, I can do it in 10 hours. Why on earth I'm gonna use it? So but I would love to hear from you how this is changing, because I bet if engineers it's taking them 10% of the time, they're not charging 10%. They're telling maybe the clients, you know what, I'm gonna charge you a little bit less, but then instead of me taking 2 months, I'm gonna do it in 2 weeks. I feel then there is the extra value for the client, because you might be charging the same, but it's taking you, I don't know, 20% of the time, which it's money in the end. It's money for the owner. I don't know if you can tell me more about that.
No, definitely. Yeah. So I think at different places you see this changing. So one thing what I really like as an example is that so this is an example of the civil industry, but there's in the Netherlands there's a project. Well, as in I think a lot of places there are a lot of civil infrastructure, sorry, which are sort of out of lifetime, right? So we have a lot of bridges in the Netherlands that were built in the 50s or 60s, and now they're sort of end of life, and now it's okay, we need to do something with them, we need to reassess, maybe they can hold, etc. So this is a really big thing. So, and there's of course a lot of repetition there, but again, there all the bridges are different. So basically, normally what they would do is they would sort of just do a tender and say, okay, can we need these hundreds of bridges that need to be reassessed, and then engineering firms can basically come up with a contract. But what they did now is that they said, okay, actually what we want software, basically. So we believe that this can be automated. There's a lot of repetition. So instead of asking for, just tell us how many hours you need to do the calculation, we want that you actually develop a tool with which we can then actually do that ourselves. And that's, I think, super interesting, because then you are really challenging the industry to automate this and to create software and to really make this digital transformation. So I think that's one interesting thing. And another thing, and that's indeed what you also see, is, let's say that as an architecture firm or as an engineering firm, when you internally, because that's of course the challenge, right? When you internally invest in developing stuff, how do you actually also earn that back? And there I do see customers that we have who are more creative in these kind of things. Instead of indeed saying, okay, I have just a lump sum project, I start to do a fixed price and then saying, okay, we can do, because we have automated this, we can do this really quickly. But, and I think also you can be quite transparent about that. If you say, okay, we internally, we have invested this to develop this tool. Yeah. And that's why there's a certain price for it. If then also for the customer, because indeed, if you have an answer a lot more quickly, that's often, of course, also for a contractor or for a project in general, very valuable.
Yeah, and even if you think about the type of contract, like an owner would always prefer to do close budget than doing T&M, right? Because you know exactly how much you're going to spend. So that's already a win for the owner. And if you're able to make it faster, that's a major win. I love what you said about the bridges and all that. Like I think it was the bridge, the first steel printed bridge in the world was built in Amsterdam, right?
Yeah, it's indeed in the city center of Amsterdam. Yeah, you have all the canals, and it was a bridge over one of these canals. Yeah,
That was really interesting.
yeah,
But then changing gears a little bit, I'm going to take advantage that you work with engineers so much. What do you feel, or if you can give me let's say a ranking of what are the tasks that people use or automate more with VIKTOR nowadays? And I'm just curious on that. Not necessarily what you can take more advantage of it, but just really what people what they're using them more for.
Yeah, so where we really started, which was where also VIKTOR in the beginning was used for a lot, was structural engineering and geotechnical engineering. So those were, let's say, the first two niches where our platform was used a lot. And then that can be in infrastructure, but also in building, etc. So what you typically see there is that if you look at, let's say, a workflow that a structural engineer does, it's often consists of different let's say most of the engineers don't do hand calculations anymore. Well, maybe a few to check, but at the end, most structures are engineered in with using finite element analysis, for example. But next to that, that's not all right. Next to that, you're also often using Excel to do some checks, or other software packages. Maybe you do the main structural calculation in your finite element package, but then you do your reinforcement design. Maybe you use something else to do those reinforcement checks. So there's just a whole bunch of different tools that these engineers use. And then if you look at it a bit broader even, then they work in a team, right? So then at the end, the structural engineer, for example, gets input from the designer who models the building, right? For example, the Revit model is input for the structural engineer. So actually, there's already interaction there, and then and everything is sort of, it's sort of a linear process, but it's actually happening in parallel, right? So it's not that, okay, we've totally finished the Revit design, now the structural engineer can do his job. It's just back and forth the whole time. So that's one thing. And then if you look at also the geotechnical design, for example, there's also a lot of interaction there. And then, of course, within the whole project team. So this was really where VIKTOR was first used for. Focused a bit more on the analysis part of the project, so structural analysis, geotechnical analysis, and then integrating all kinds of different calculations from one central place, so that you can do both generate automatically the finite element analysis, get your results back, also based on that do, for example, a geotechnical analysis, or push or pull information from your Revit model, those kind of things. Yeah.
That's interesting. And I'm also curious on the fact that if I'm an architect, would you think that, I'm not saying tomorrow, but in a short term or midterm, like and for certain specific buildings, right? Not for everything. But I was thinking, like, as an architect, if I'm doing, let's say, residential, which is pretty easy, standard, and the calculations for a structural engineer are pretty common, right? You don't get weird shapes or anything like that. I was thinking that maybe in the future, structural engineers are not gonna provide the service, but they're just gonna provide let's say, a product through VIKTOR. Let's say, hey, this is the automation, and you as an architect can run it automatically. So once you're done, sure, an engineer is gonna give it a quick look to make sure everything makes sense before signing it, right? But you think that that's gonna happen, where engineers are gonna use your platform to actually make life easier for them and also for architects, so they can automate the engineering calculations as well?
Yeah, I believe so. So I think this is all, of course, also always a bit of a tricky, maybe, thing for engineers, because at the end, of course, a structural engineer has certain expertise that is really necessary. But I totally agree with what you say, and what we also already see is that, let's say, at the end, there's I think, as an engineer, for example, structural engineer really thinks you should think about in at first, okay, how, I don't know, how do I sort of, what are the boundary conditions, etc., and what loads do I need to apply, and what are sort of the main structural solutions. But where I think there's a lot of repetitive work, and where you don't add that much value, is in all the iterations, right? So every time something changes, you go through that same process. And there, I think it would be very powerful if then, let's say, if an architect is, for example, just playing around and changing things, that the whole structural analysis can be done automatically. And then indeed, at the end, of course, before you go to production, a structural engineer then checks again, okay, is everything correct? But especially, I think, in all these iterations, and then integrating different things and making sure that there are not in every step there's sort of manual work to be done. I think then that can save so much time. From everyone.
No, absolutely. And I also think that maybe it's a little bit unfair speaking about a structural engineer, because engineering, because it's the hardest, and is the one that, I mean, you cannot miss, right? Like, if you make a mistake, people can die. But I do feel that there are so many other engineers, like MEP, for example, that there is so much more flexibility there, where if you make a mistake of, hey, less than 10% of the volume of air, you can correct it, right? Like, you just change the HU, and you change the size of the ducts a little bit, and that's it. You fix it, and everything works. So I do feel that in the in-betweens, that there is also a lot of value that might be immediate value, compared to structural engineer that, like you said, there's always going to be someone involved, because nobody's going to sign a structural design unless they have reviewed it, because it's too complex, right?
Yeah, indeed. And I think what I really like about this is we've been through this process so often, where basically when you talk about, okay, let's see how, if your work can be automated, for example, then at first people are quite nervous. But then when you go through this process, because in the beginning we were still also doing a lot of that, we developed the apps for our customers. And then but what you then noticed always in this process, at the end, people really like it, because what they end up with is that they can still, the hard things, they still need to do, right? Really thinking about, okay, how do we in principle are going to solve this? And then the repetitive work, so sort of, okay, now again, we need to change something. You need to update your reports. How often does that happen, right? That you have your engineering report, then something changes. You have to update everything, all the tables, all the figures, whatever. And then if people start to notice, hey, that's actually the work that you can really easily automate, then people just can spend more of their time on really, solving the puzzles, let's say, and automate the repetitive work. So I really believe also that next to that it also leads to just a nicer job as an engineer or an architect when you automate the boring stuff.
No, absolutely. And I do think also the fact that I think in the past, like this was great, but it was also limited to most of big firms because
Yeah,
you might need someone who knows how to code, right? To use
yeah,
Python and
yeah,
actually code the stuff, and you need to have the money to have someone who
yeah,
knows that. But I know things are changing with LLMs, and I know you're
yeah,
getting involved as well
yeah,
with the beta you have released. So uh, I would love you can tell me more about how you're allowing anybody to actually
yeah,
create apps without programming knowledge.
yeah. Yeah, cool. Yeah, so indeed, as you already also mentioned at the beginning, our platform is in principle, you could see that, yeah, it's a low-code platform to build apps for yeah, for the engineering, AC and engineering industry. And in principle, it's based on Python. So you write, but you only need Python to create the apps. So you don't need to be basically, you don't need to have any front end or back end knowledge. It's just Python. And then we have a lot of things out of the box. And because of that, it's already, let's say, yeah, a lot easier to create a web application compared to when you would start from zero. But yeah, as I mentioned, of course, you need Python knowledge to do that. And of course, not all engineers, not all architects have Python knowledge. So what we are now, yeah, have been developing since the beginning of this year is, yeah, that we use large language models to actually create the Python code for the app. And also, it happens fully in the browser. So first, when you when you developed Victor apps, you also had your code yeah, on your laptop basically, and there was quite some, and you needed to have Python installed, for example. Well, that's not for everybody that easy to do, for example, right? So now this is all in the browser. So basically, you can just, and you can try it out yourself already. We released it in beta. And how it basically works, you have a prompt and you can say, okay, build me an app with which I can, for example, in which I can upload an IFC model and retrieve this and this information. Or I create an app in which way I can parametrically design this and this structure. And then basically based on that prompt, it generates the Python code. But also immediately you get the app and you just have the functioning app in your browser. You can try it out and then continue prompting, or you start to manually change the Python code. Yeah, so this is, I think, very exciting times for us because now we really see that also people without Python coding skills can also build these apps. And because these large language models are just, we use a Claude model as a fundament. Yeah, these are already so good basically in writing code. So with that as a basis, plus let's say some smart things that we do around that, yeah, we just see that this is working really well so far.
Yeah, and uh, I think it's lowering the bar because even if
Yeah,
I think low code it's an example that it lowers the bar a little bit, but when you try to explain low code, not only Victor, right, but like Dynamo, Grasshopper, or any low
yeah,
code platform, it's still really hard to explain it to people, and it's fair. People, I'm an architect, and or people who are architects, they don't want to learn this. They want to
yeah,
design. They want to do whatever they're good at.
yeah,
So, but it's different. I feel when you can just do a prompt through a text,
yeah,
and even more, I could see this on like senior engineers. Like I'm a senior
yeah,
engineer, I know exactly what I want to get, and I can
yeah,
explain it properly. So then, if I create a workflow, I can either give it to a junior engineer,
yeah,
or the question I have is, do you also foresee that in the future, like let's say I'm a structural engineer that I'm really good, and I've
yeah,
done this 1,000 times. So now I might want to sell this automation, and
yeah,
people might want to buy it because they know it's backed by me, that I'm a great structural engineer. I have done this
yeah,
1,000 times, and if there's a bug or something, I will fix it.
yeah,
Do you think this is going to happen also through your platform in the future, or
yeah.
it's not something you want to do?
Well, this is actually already happening. So we indeed have people who, let's say, codify their knowledge, to say it like that. So they have a lot of knowledge in a specific thing, and then on our platform they build an app, and then they actually sell this app basically as just a sort of just a SaaS, software as a service thing. So that is something that is already happening. Which is, I think, very interesting indeed. But I also, the other thing which is, I think, already interesting is, okay, how can I also, let's put the situation where this engineer just works in a company, right? In a bigger company. So how can you make sure that that also the knowledge, and that's, I think, in general, in a bit abstract, okay, how can you make sure that we can capture the knowledge of people in a tool or software basically, and that then other people can actually reuse that. I think because now I think so many times sort of sort of similar problems are being solved by different people. So what I really like as an example is Python. So you have Python, this super rich ecosystem of all kinds of packages, right? So if you use Python, there's a pack, and you think about, oh yeah, well, this is quite standard. Then probably there's a package, and then somewhere, someone at the other side of the world actually made that package, and then basically codified the knowledge in that package, and then you can reuse it. So I think, and that's the thing that we are working towards. Okay, how can we make sure that you can really easily put your knowledge in a certain app or in a tool, and that then other people can really easily reuse that in your company, and then that you combine that, etc. Yeah.
That's great. Um, Also, a quick question is, what's you have spoken about so many great things, like people being able to share their workflows, being able to create them with no coding experience,
Yeah.
and being able to use it in basically any part of the design or engineering process.
Yeah.
What's coming for VIKTOR in, I don't know, 3-5 years? What are the next things coming for you guys?
Yeah. Yeah. So I think, in general, right, we live, I think, in a very special time in terms of technological development, with everything that's going on with large language models. And maybe some people say, okay, maybe it's a hype, but personally, I don't think this is the case. If you already see at basically how much the adoption is of these kind of tools. So I think throughout the coming years, this technology, that's, I think, one very important change that I think will affect, everybody. Um, and so for us, what we really think about a lot is, okay, how can we then, uh, um, how will this work in our industry, right? And how can we use AI to the fullest in our industry? And then, let's say, how we foresee that a bit is that you can also get towards these more agentic workflows. So that would mean that, the example that you just gave, let's say that you can have, we believe that at some point you can have, you can see it as sort of colleagues who are actually agents, right? So you can have, for example, maybe a junior structural engineer colleague, and basically the task that you would give maybe as a senior engineer to a junior engineer would be something that you can give to an agent. And then this agent, is trained or has knowledge on this specific thing. Um, and then have further on, it's more about how can you then even let these kind of agents collaborate with each other. So maybe you can have just an architect agent working together with a structural engineering agent and with an MEP agent, and that they work together to come up with a design. So this is, I think, a bit further in the future. But with our platform, we believe that this is where, let's say, the technology, the world is going. And with our platform, we really want to support these kind of things as good as possible, by allowing that you can basically put your knowledge in an easy way in tools, and then reuse these tools, and also have, let's say, large language models be involved in that, and that you can combine this all to further automate these workflows.
That's a great vision.
So
And
I hope I didn't get too abstract, but yeah.
no, it makes sense. It makes sense, and it'll be the ideal world, I guess, for architects and engineers.
Yeah,
But I know you're a busy guy, so I don't want to take more of your time. But before we wrap this up, can I ask you a couple of ping pong questions?
of course.
Okay. What do you think is the next big trend in the AC?
So one thing is what I already mentioned, of course, but I think the other thing, and that's also really struck me in the from next build, going to the browser. I think that's one thing which is a very big trend. It's actually there's still a lot of desktop software being used. I think that will, in the coming years, that will move to the browser. And with that, you have a lot of opportunities, right, for collaboration. People are and using more cloud computing, etc. But I think, let's say, moving to the browser, it seems almost sort of logical, but I think this is a very important and big trend in the coming time.
Absolutely. If you could mention a great AC startup besides VIKTOR, we know it's great, but another one in the AC, which one would you or program? It not necessarily has to be in a startup. It can be a program that you think is great.
Yeah, so one of the things, so it is, I think, still in the startup scale phase, is Qonic, Qonic. Sorry, I don't exactly know how to pronounce it, but it's Qonic. So I also saw their demo, and what I really like about them is also is that, they had sort of these 3D models in the browser, but then all the way from, let's say, the whole city towards sort of the detailed level, and you could sort of go through that in a very fluent way. So I was really impressed, with what they showed.
Yeah, the smoothness of the viewer was
Yeah,
insane. Yeah,
yeah,
I
yeah,
saw that one too.
yeah.
If you could collaborate with any person in history, which person would you choose?
Now, so that's a good one. So I think still here, let's say my aerospace heart. That's the first thing I think about is. So I don't know if you know. Have you ever heard about Skunkworks?
No.
So it was basically it was a division of Lockheed Martin, and they were so they did a lot of, they designed and built amazing aircraft. So for example, they had the Blackbird, which is, I think, still one of the most amazing aircraft ever built. It's it could fly like Mach 3 or something, so 3 times the speed of sound. And they were able and in this division they actually were able, and this is so in an era where they didn't have, I guess, computers at the time, right? Almost. So they super rapidly were able to design and build these aircraft. And Kelly Johnson was sort of the technical lead there. And apparently, so there's a really great book about it, which is actually called Skunkworks. I can really recommend it. So I would really like to work together with him, because I think that he had, just so much engineering feel. Actually, he could sort of design an aircraft and something very innovative based on his sort of engineering gut. So I think it's really impressive to work with. I would have really liked to work with him in some way. Yeah.
That's really cool. I didn't know, but I loved reading, so I'm gonna give it a look for sure. Um, and then finally, what's your favorite building in the world, and have you ever visited?
My favorite building in the world. Um, yeah. So that's a good question. Um, so I think Yeah, sorry, I'm taking some time, but
No worries.
yeah. So of course, I'm not an architect by background. So I think for architects, this is sort of a question they can immediately answer. Um, but what?
I can give you help, but it can be whatever. Like it can even be your house when you were a
Yeah,
child, or it can be whatever building that you feel, or it can be a hangar of a plane. Whatever it
yeah.
makes you feel, I don't know, great, I guess.
Well, then I do have something, and maybe it's really a weird example, but um, what I tend to find really impressive are these really massive things, right? So and I know that and it's of course a very sad story, that the Chernobyl disaster. But they built around that the nuclear factory. They built this huge concrete, just thing that they just completely put around it. And actually, I would really like to see that at some point, because I think it's just so impressive. Oh yeah, okay. Now coming to mind related to this, which is a building I actually saw. It's actually the vehicle assembly building in on Cape Canaveral, so on the launch base. So this is the building where they. So it's just a box basically, but then a box of, yeah, 120 meters high, wide, and then they used to already assemble the Saturn V rockets in there, and then also the space shuttle was assembled in there. And I have visited it once, and I was again just so amazed by the sheer size of this building. It's just, yeah, huge. Yeah,
I would never expect less from a aerospace engineer.
yeah, yeah,
It's a great building, sure.
yeah.
And before we say goodbye to each other, can you tell everybody where they can know more about VIKTOR or contact you as well?
Yeah, yeah, of course. So first of all, we have our website. It's just VIKTOR.ai, as you can see on my shirt. So there you can actually just get information on our product, but also I explained about the app builder. So basically, if you just go there, you can start for free. And actually, yeah, if you go there now, you can have your first prompt and first app in a few minutes. So that's something where you can go. Also, you can go on LinkedIn. We are quite active there as well. So we show a lot of stuff, what's going on. And also personally, you can also find me on LinkedIn. So yeah, so very open to connect with people in the industry.
All right. Thanks so much, Stijn, for this conversation. It was really interesting, and what you guys are building is amazing at VIKTOR. So congrats on that, and hope to see more of VIKTOR in the future. All right.
Cool. Thanks so much, Valentin. I really enjoyed the conversation. So thanks for inviting me, and looking forward what's coming next.
Absolutely. Thanks so much for your time, and see you next time. All right.
See you. Bye-bye.
Bye.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'd love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.